discussing about the capacitors and the types of the capacitors. All the capacitors commonly used in electronic circuits divided may be divided into two general classes, that is fixed capacitors and variable capacitor. Fixed capacitors may be further subdivided into electrolytic and non-electrolytic capacitors. Fixed capacitors. Fixed capacitors can be grouped into two classes as non-electrolytic type. It includes paper, mica, and ceramic capacitors. Such capacitors have no polarity requirements, that is, they can be connected in either direction in circuits. Fixed capacitors. Paper capacitors, it consists of two thin foil sheets which are separated by thin tissues paper or waxed paper. The sandwich of foil and paper is then rolled into cylindrical shape and enclosed in a paper tube or encased in a plastic capsule. The lead at each and end of the capacitor is internally attached to the metal foil. Shows the microfarad tubular paper capacitor of maximum AC voltage rating of 2000 volts, whereas polyester capacitor having molded plastic box encapsulation suitable for using printed circuit boards. Paper capacitors have a capacitance range of 0.0012 to 2.0 microfarad and a working voltage rating as high as 2000 volt. These specifications are usually printed on the capacitor case. Paper capacitors have large physical size as compared to their capacitance and also become inefficient as the frequency of applied AC voltage exceeds a few megahertz. These facts prevent their use in most FMTV circuits, except in low frequency portions of the circuit, that is in audio stages. And the second one is mica capacitor. It is a sandwich of several thin metal plates separated by thin sheets of mica. Alternate plates are connected together and a lead attached for outside connections. The total assembly is encased in a plastic capsule or backlight case. Such capacitors have small capacitance values at high working voltage ratings. Once such capacitors were used extensively in radio circuits, but of late they have been superseded by ceramic capacitors because of excellent properties of ceramics and their economy. And the third one is ceramic capacitor. Such capacitors have disc or hollow tubular shaped dielectric made of ceramic materials such as titanium dioxide and barium titanate. Thin coatings of silver compound are deposited on both sides of dielectric disc, which acts as capacitor plates. Plates are attached to each side of the disc and the whole unit is encapsulated moisture-proof coating. Because of the very high value of the dielectric constant of ceramics, the disc-type capacitors have very large capacitance compared to their size. In the case of tubular ceramics, the hollow ceramic tube has silver coating on the inside and outside surfaces. The capacitance range varies from 1 to 500 pF. with a working voltage rating exceeds 10 kilovolts. Ceramic capacitors have many advantages to compare to mica and paper capacitors. The fourth type is electrolytic capacitors. These capacitors are called the electrolytic because they use an electrolyte as negative plate. The capacitor consists of a positive plate of aluminum, an extremely thin insulating film of aluminum oxide as dielectric medium. It is electrochemically deposited on the surface of another itself. An electrolytic borax, an absorbent gas saturated with the electrolyte, is kept in constant with the dielectric. The second aluminum plate serves nearly as contact to the electrolyte. It forms the negative terminal such as capacitors is made as described below. A thin strip of aluminum is coated with a molecular thin film of aluminum oxide by an electrochemical process. It is covered with a layer of gas soaked in the electrolyte of borax. On top of this is another metal plate in contact with the electrolyte, which in relative is the second plate of the capacitor. The entire sandwich is rolled up into a compact cylinder and placed inside a metal cylinder. This enclosing cylinder contact the outside metal foil of the capacitor and serves as the negative terminal. Such capacitors are made as single capacitors or with two or three capacitors in a single container having common negative terminal. The outside metal cylinder is usually enclosed in a paper tube in order to insulate it from components and to protect radio techniques from shock. Because of extremely thin dielectric film, such capacitor possess very large capacitance, large from 1 μF to 1000 μF in very compact sizes. Hence, they are used where lot of capacitance is required in a small space. Since they use an electrolyte as the negative plate, electrolytic capacitors are classed as polarized capacitors. That is, they must be connected in the circuit according to the plus and minus marking on the case. If this is not done, the capacitors may become short-circuited or getting overheated due to the excessive leak current through its dielectric. Moreover, reversed polarized reversal in gas formation which may cause the capacitors to explode. Electrolytic capacitors are frequently used in the filter circuits in order to remove AC ripple from the power supply. They are also used as blocking or coupling capacitors for blocking DC in a circuit but allowing AC to pass through. The two disadvantages of electrolytic capacitors are that they are polarity sensitivity, have low leakage resistance because the oxide film is not a perfect insulator. The words they have high leakage current which can become troublesome. And the fifth type is variable capacitors. A variable capacitor is one whose the capacitance can be varied usually by rotating shaft constant consists of two sets of metal plates separated from each other by air. One set of plates is stationary and is called stator. It is insulated from the frame of capacitor upon which is mounted. The other set of the plates shaft and can be rotated. That is why it is called a rotor. By rotating the rotor with the help of suitable knob, rotor plates can be made to move in or out of the stator plates. Capacitance is maximum when rotor plates are fully in and maximum when out. If n is the total number of plates and d is the separation between any two adjacent plates, then the capacitance for a dielectric is n minus 1 epsilon naught by d. When two or more such capacitors are operated by a single staff, it is known as a ganged capacitor. That is, one having two separate variable capacitors in one unit rotated by a single control. Commercial receivers and those used by shortwave listeners often have a variable capacitors with their gangs. Another type of small variable capacitor which is often used in parallel with the main variable capacitor is sometimes known as trimmer and sometimes as padder. It is used primarily for making fine adjustments of the total capacitance of the device. A trimmer consists of two small flexible metal plates separated by air or mica or ceramic slab of dielectric. The spacing between the plates can be changed by means of a screw adjustment. As the screw is turned inward, plates are compressed and its capacitance is increased. And thank you.